Hello everyone. My name is Jose Gansman. We present the Z99 apparatus. Z99 is a multifunctional device. It allows plotting, cutting, drilling, milling and laser operations. The construction is straightforward. We claim that everyone who can drill a hole in an MDF baseplate is able to make it. The complete construction and user manual is in the book, Build Your Own 4-Axis Multifunctional CNC Machine. The book is available at https://www.electa.com. We give an overview of the construction of a tabletop version with linear shafts of 500 mm. Start with an MDF baseplate of 610 by 850 mm, thickness 18 mm. Position the auxiliary pieces and the 6 linear shafts on the baseplate. Drill 8 pilot holes 2 mm. Draw also the borders for the 120 mm cooling fan. Mark the holes for fixing of the PCB below the cooling fan. Remove everything and drill 8 9 mm holes. Drill also 4 holes with 4 mm diameter to fix the PCB. Saw the 120 mm square opening with a jigsaw after drilling a pilot hole of 9 mm. On the bottom of the MDF plate, fix the 4 short table legs. Fix reinforcement and wiring carrier rod with non-penetrating wood screws. Insert some ties in the rod. Fix the 4 Y-steppers in the corner pieces with 3 mm bolts and locking washers. Fix the 4 Y-corner switches with 2 mm bolts. Fix the 4 pulleys, 16 teeth, width 10 mm for the GT2 belt. Construction of right X terminal. Fix the 2 parts and 4 LM12U holders together with 8 ties. Remark that the 2 letters are face frontwards. Fix the stepper motor and X corner switch. Construction of the left X terminal is similar. Slide the 2 right linear shafts of 12 mm in the LM12U holder of right terminal X. Slide the 4 ends of the linear shafts in the 2 right corner pieces. Fit the YGT2 belt, width 9 mm on the pulleys of the corner pieces. Insert the belt in the right terminal X as deep as possible. Repeat the same procedure for the left terminal X and left corner pieces. Fix the 2 rightmost corner pieces on the MDF baseplate with 4 8 mm bolts and nuts. Winged nuts are preferable. Tension the right Y belt by moving the stepper motor in direction of the arrows. Prepare the Z carriage. Fix 4 LM12U holders with 8 ties on the back part of the Z carriage. Slide 2 linear X shafts of 12 mm in the Z carriage. Insert the ends of the 2 X shafts in the right X terminal. Insert the ends of the 2 X shafts in the left X terminal. Fix the left corner pieces with 8 mm bolts and nuts on the MDF baseplate. Attach the Y corner pieces and the GT2 belt, width 9 mm. Fit the X GT2 belt, width 9 mm on the pulleys of the X terminals. Insert the belt in the backside of the Z carriage as deep as possible. The main skeleton of the tabletop version is ready. At left is a table leg of 40 cm. The wiring to the Z carriage is attached to it, to keep it out of the way. This was an overview of the skeleton construction of a tabletop Z99 version. The construction of a standalone version with longer table legs is very similar. The length of the MDF baseplate is longer to fit the table legs. Example of further assembly of the Z carriage for plotter or cutter. Front and mid part of Z carriage are fixed together with the Z motor. Fix the Z corner switch with 2 mm bolts. Insert 6 hex bolts, diameter 4 mm. Fix with 4 mm nuts. The up-down part of the plotter and cutter Z carriage has two parts. In the upper part fix the activator for the Z corner switch. This is a 4 mm bolt, length of 20 mm. Fix the trapezoidal nut with 4 3 mm bolts and nuts. In the lower part fix 4 LM6U holders with 4 ties. Screw the trapezoidal screw in the nut and fix it to the flexible coupler M5M8. Slide 2 LM6 linear shafts in the front of Z carriage from above. 2 springs of 5 turns are between lower and upper part. Lower and upper part are loosely connected with 2 ties. At this stage you may already connect a pen for your first trial. Fix the front and mid part of the Z carriage to the back part with 6 winged nuts and spacers. Mounting of another Z carriage is easy. It only requires to switch the connection to the Z switch and the Z stepper motor and to fix the 6 winged nuts. Manufacturing of the PCB, connection of steppers and corner switches is thoroughly covered in the book. Time for some action. Launch XYZ. X. If this is the first time launch, open the setup. Verify the choice of the correct comport number. The correct comport number is the number that is added to drop-down list when the Z99 is connected. Verify also that the length of Z shaft is in millimeters is OK. If the power supply of the Z99 is off, turn it on. Quit setup and start the command mode. Below action select plot. Set the Z travel speed. This is the speed when the pen is up. Set the Z work speed. This is the speed when the pen is down. Set speed for Z movements of the pen. Set the Z position for pen up and pen down. The Z position is the number of millimeters below the Z switch. Make a test trace on a scrap paper to verify the settings. Quit the command mode. Start the plot module. Open a HPGL file with menu. Set the desired output format and start plotting. Secondary changes to speed and Z position are possible during operation by selection of the checkbox pause. The Z99 has many possibilities for use. We give a few examples of plotting, cutting, drilling and lasering. Here is the plotting of a simple drawing. This takes only a few minutes. Plotting a large format schematic is possible. This takes some time, when there is a lot of text in the drawing. It is possible to plot a PCB with etch-resist ink. Etching with iron trichloride is then possible. Etching with iron trichloride requires some precautions. Etching requires a good plotted design and some experience to obtain a good result. Plotting a circuit with conductive ink is very interesting to make a quick prototype with dual inline components. The tip of the pen has a diameter of 0.4 mm. Make the tracks of the PCB wide enough, so that each track is plotted at least 3 times. With a few precautions, soldering of the plotted PCB is possible. Example of use as cutter. Paper cutting is a possibility. Vinyl cutting allows to cut nice adhesive letters. Use flat sheets of vinyl and a knife of 45 degrees. Do at first some calibration cuts in the command mode. This is an example after transfer to another surface. Example of drilling. Drilling a PCB with 0.8 mm drill. Drilling of other materials is also possible. Milling. Milling a PCB is possible. Fixation of the PCB is necessary. Put a plastic foil below the PCB and a drop of oil on the PCB. For optimal results, use shorter X and Y linear shafts. It is then possible to use a spindle motor. Operation with a weak laser. Always use precautions when working with a laser. Wear quality protection goggles. Keep fire extinguisher at hand. Make sure that other people cannot enter the room. A weak laser of 500 mW allows engraving of many non-reflective surfaces. A weak laser of 500 mW allows also cutting of a solder paste mask for applying of solder paste to an SMD PCB. This is an example of laser engraving. The substrate in use is a thin MDF plate. Other suited materials for engraving with a weak laser are wood, leather, fabric or dark cardboard. Other possibilities are covered in the book. The book explains also how to make suitable HPGL, Gerber, drill and G-code input files in several freeware programs. Thanks for watching.